Now let's see one more sum of evaluation. We need to prove that integration 0 to infinity e raised to minus t sine square t divided by t dt is equal to 1 by 4 log 5. Students, it is very easy to understand that the sum is of evaluation, that is, we need to evaluate by just understanding my limits of 0 to infinity, which is standard limits of Laplace transform definition. I start with solution. Again, first we need to find what is the value of s which we are going to substitute in the last. So I say Laplace of f of t, that is 0 to infinity e raised to minus st f of t dt. So when you compare, you get e raised to minus t is compared with e raised to minus st, so you get s is equal to 1. So this is the final value which you are going to substitute, and your f of t is nothing but sine square t divided by t. So you need to find Laplace of sine square t divided by t, and the last you need to put value of s equal to 1. So Laplace of sine square t divided by t is nothing but Laplace of 1 minus cos 2t divided by 2t. So we can say 1 by 2 constant, Laplace of 1 is 1 by s, Laplace of cos 2t is s divided by s square plus 4. So now we need to apply effect of t also. So I just put here, this was Laplace of 1 minus cos t and 2 was outside. So effect of t is nothing but integration s to infinity with respect to ds, which finally gets 1 by 2, and 1 by s is log s minus, now here hope you remember adjustment of 2, which gives me 1 by 2 log of s square plus 4, where your limits are s to infinity. Take 1 by 2 outside, which makes 1 by 4, and which makes here log s square minus log of s square plus 4. Now s to infinity, that's it, 1 by 4 log of s square divided by s square plus 4, which gives me reciprocal of this, that is log a by b. S to infinity is nothing but 1 by 4 log of s square plus 4 divided by s square. This was a Laplace of your function. Now last is, we need to substitute s equal to 1. So I can say I equal to 1 by 4 log of, when you put 1 here, that becomes what? 5. And I think that is proved to be RHS. Now third sum, find integration 0 to infinity e raised to minus t ERF c root t. Now this is also error function with just a c, that is nothing but a modification with the error function. Now I start with solution. Now this sum is of evaluation, so we can compare with Laplace of f of t, that is 0 to infinity e raised to minus st f of t dt. So while comparing, I get s equal to 1 and your f of t is equal to ERF c root t. Now how to exactly solve ERF c root t? I'll just mention one formula which you need to remember it very well. Now ERF c root t is nothing but ERF of root t plus ERF c of root t is equal to 1. You need to remember this formula. We can't find directly Laplace of ERF c root t. So first we need to get ERF c root t as 1 minus ERF of root t. So I can say Laplace of ERF c root t is nothing but Laplace of 1 minus ERF of root t, which can be written as 1 by s minus ERF of root t is 1 upon s into under root of s plus 1. So this is a Laplace of ERF c root t, where I can put value of s. So value of s is nothing but s is equal to 1. That gives me I equal to 1 upon 1 minus 1 divided by 1 under root of 2. So which gives me 1 minus 1 by root 2, which is nothing but root 2 minus 1 divided by root 2, a constant value. Thank you for watching in 5 minutes.